In the earlier session, obviously, we were discussing more into the cyber security part that you probably might have seen payload analysis and whatever that we had. But okay. Okay, so let's start with this. So over the next 1 hour that what we had, so we will try to explore that how the blockchain data and particularly what I call as Ethereum, okay, can be analyzed using machine learning to detect any sort of anomalies, you can say any sort of frauds and the emerging threats. So we basically first have to understand that we are living in an era where the blockchain is not just about crypto forensics anymore, okay, and it has become a core infrastructure for decentralized finance, and people called it as DeFi, DEFI. So this is decentralized finance, as well as we will look into something what we call as smart contracts and even the digital identity systems that we have today. So before I begin into this, remember that blockchain adoption grows, so it has some sort of security challenges, okay, like for example we have scams, we have fraudulent transactions to sophisticated smart contract exploits. So we are having lot many of these days that are very much popular. So Ethereum, being one of the most actively used blockchains, has been both innovation, I should say, and exploitation as well, okay. So that is why traditional rule based systems cannot keep up with the volume, they cannot keep up with the velocity and the variety of blockchain. So that is why where machine learning comes into the picture and play, helping us to identify the abnormal patterns, okay, because why? The suspicious transaction and malicious actors are in real time, and that is what we have to actually find through not only rule based, but obviously we have to try something what we call as machine learning. So the purpose of this particular session, that is very crux that we have kept. So we are going to bridge two powerful domains. One is blockchain technology and the other is machine learning. So we will try to understand that in case if it is possible, how to apply machine learning or machine learning techniques to detect the threats within the Ethereum massive and public available transaction data. Okay, so I will give some sort of view based upon the data sets that we use, and this is not just a theoretical topic, you should understand, because we have only dedicated an hour to this. Financial institutions, if you talk about crypto exchange, if you talk about cyber security firms, they are all actively developing what I call as AI driven blockchain analytics tools, and for not even fraud detection, but there are multiple other scopes that we try to do. So let us move into this. So this is what we have set the session overflow or the flow that we will be following, but we'll try to understand the blockchain threat vectors, and I will be more specific to the Ethereum only. So we probably miss some time down the line because obviously you cannot cover everything today. So we can start by examining the main attack surfaces in Ethereum, okay, from smart contract vulnerabilities like re-entrancy and overflow to transactional and DeFi based threats, okay. We can also review at some point of time in your classes, or if you are doing some courses, to review the real case studies such as DAO attacks, okay. I hope you have heard about this and I will actually tell you something about that. Second major thing, you have to identify how machine learning models can help you. See, you have to see the machine learning models can detect irregular transaction patterns and they can actually find the fraudulent behaviors. So there you have to actually use machine learning. But how? So we will talk about supervised, unsupervised and graph based. More importantly, these are the leading approaches that make sense into blockchain. Obviously supervised and unsupervised will do, but you have to understand about the graph based capabilities. So in case time permits, I will let you know. Third very important thing is exploring the data sets and research techniques. Okay, so sometime you have to move to the data side. You need to understand what Ethereum data sets are available, how they are structured and what features. Features may be the gas price, the frequency and the address relationships that we do. Okay, so we can extract for modeling. Okay, because there the ML part will come into, and probably we have to listen about or learn about the data processing challenges, because you're going to handle what I call as imbalanced data set and there will be a lot of noise into that. Okay, I hope you probably understand the imbalance factor and if there are noises to that or not. And last but not the least, at some point of time, not in this class, you have to examine the practical approaches and tools. Okay, what exactly I mean by that? We will explore at some point of time the hands-on and the workflows, like using APIs like EtherScan. So EtherScan is an API that I use where there is Ethereum ETL, there is something what I call as Dune Analytics. So there are a lot of APIs that are free and as well as premium which are available. So you need to actually think about that. And this is a lot practical aspect, but based on whatever the time we have. So you can think about basic anomaly detection model at some point of time using Python and libraries like scikit-learn. And there is one more library that I can't recall at this point of time is isolation forest. So you can use that. Okay. So this is what the objectives that I have kept over here. And this is going to be something in hybrid of conceptual understanding, technical insight. And this will not be that hands-on, but I will try to actually let you know what exactly we mean by these approaches. Now, what is the introduction part I've already given, but what exactly the motivation that we have? So why security in blockchain matters? That is what I'm trying to make you understand as of now. So why does security matter so much in blockchain, especially in Ethereum? See, blockchain was designed, in case if you know that, to be trustless. I hope you understand this. Trustless, that means there will be no single authority, everything is transparent and transactions are what we call as immutable. Okay, so both that transparency and decentralization, if I talk about, they come with some sort of unique risk. Okay, so those risks somebody has to keep in mind before you apply all this. Like for an example, if I talk about a unique risk, so once a transaction or contract is executed, we cannot reverse it. Okay, obviously you understand this. This is the first type of risk, I should say. Second category that could be, there is no central regulator or a rollback mechanism that we have in this case. Okay, so we cannot have a central regulator. That is why the Bitcoins and everything has not been actually regularized in India. So we do not have any specific guidelines on that also. Attackers can exploit the code. They can exploit the logic, they can even actually exploit what a user behavior is. Okay, so these are not just networks, you have to think about these risks. So unlike, the point is, the traditional banking systems that we have, SBI, whatever that we are trying to follow, if someone like an attacker can drain a wallet, I hope you understand a wallet in blockchain where all these cryptocurrencies and all that kind of Bitcoins management is done. So suppose they exploit that up, they exploit a smart contract, okay, then there is no customer support that we have, it has gone permanently in that case. Okay, so these are certain unique risks that you have to eventually think about at some point of time. And there are certain examples, see why security is so critical in this dimension. So I will give you one more thing, you should go back and actually read about this. So we have a smart contract bug, okay, so vulnerabilities in the control code. Control code, you understand? Control code means, like suppose I was talking in the first session also, like buffer overflows. Okay, so in case if I'm not talking about buffer overflows, we have integer overflows also. So integer overflow, you understand? So you probably might be coding at some point of time in your C language and you actually declare a variable. Okay, so that variable has a specific size. That could be a signed integer and that could be an unsigned integer. But suppose if you do not have that exact upper cap, that how much a specific variable could hold it, and these checks are not basically utilized during the course of implementation, then you may land somewhere at point of time in a vulnerability. But that vulnerability first of all will be a bug, because that is done by the developer, and suppose if any attacker exploit that bug, then it becomes a vulnerability in that system. Okay, so this is what we call as smart contract bugs. Okay, I'm not talking about the vulnerabilities, that are bugs which may lead to the risk. Okay, so your implementation becomes very important, because what people do, they actually copy and paste. You work on transfer learning. I hope you understand transfer learning. Whatever that is ready made, you actually cut, copy and paste and use the entire models which are entirely built on. Okay, so that you should not do. You should properly sanitize, you should properly vet any of the kind of blockchains or whatever the machine learning models that are going to be utilized. Okay, second thing, there are words written as DeFi hacks. So DeFi hacks means these are decentralized finance platforms, okay, which are built on Ethereum, and they are the prime targets of the attackers and the adversaries nowadays. Okay, so billions have been stolen, and obviously you probably might have read that the APT groups, the advanced persistent groups like Lazarus and everybody, are trying to actually steal this kind of data. Okay, third category is rug pulls. Anybody have an idea about rug pulls? See, what happens, a developer creates a project, okay, and they attract the investors, okay, and then they withdraw the liquid amount of money, leaving the token worthless. That is what is happening. So you actually establish an entire ecosystem, you have developed the entire ecosystem, and you have certain things which are already there. But suppose if you actually move out of that ecosystem, you have to actually get rid of each and everything. But what happens? You actually leave the loopholes over there, and which are the prime targets. So these rug pulls are that which the developers have left as loopholes. Like for an example, if you are a web developer person and you are coding somewhere in Java, say for example, and you have to encrypt the entire communication channel, so you probably might be using a library called as OpenSSL. Have you heard about this? OpenSSL library. So OpenSSL is a library that is basically used to encrypt that information during the communication. But now think, if there is a bug in OpenSSL library, what will you do that? You will not be responsible for that. OpenSSL will be responsible, but you have used it over here. That is why you become vulnerable to that kind of a bug. Okay, so this is what you have to understand. But my question is, iske liye aap kya kar sakte hain? What will you do as a person if you are implementing this blockchain? A proper sanitization and a proper vet has to be done for the entire ecosystem. Okay, blockchain is immutable, it's trustless, it's decentralized. This is for sure. You maintain whatever the confidentiality, integrity of the data, but the implementing body has to take care of all these concerns. Okay, I will tell something more about the machine learning part also, what security that you have to actually enroll in this part. I will try to give you an overview of Ethereum architecture at some point of time, but obviously it's a conceptual one, but there are certain things you should understand. So I don't know if you have heard about this back or not. There are key components that we use in Ethereum. So first key component, in case if you have heard about that, can you please tell me? There is one thing, we call it as Ethereum virtual machine, EVM. Okay, so what is an EVM? As you have Java virtual environments also. So this runtime environment basically helps you to execute the smart contract deterministically. Okay, that is very important. So that every node that is there, which you are building on the blockchain, runs the same code. Okay, because of the uniqueness that you have to maintain, and you have to ensure the consensus. I hope you understand this word as consensus. Consensus means everybody should participate and say yes that I am trying to add this node. Okay, then only the transactions will happen. But remember one thing, it should also replicate the vulnerabilities across the network. Okay, suppose if there is a specific vulnerability in one node, that should be replicable to every other node, so that the other people can also join in and can see that there is a vulnerability. So this is what the part of EVM does. Okay, second thing that is very important as an architecture in Ethereum is smart contracts. Anybody has a word to say for, or a line to say for smart contracts? Kabhi suna ho aapne? A bit louder, ma'am. Agreement between the two parties. That's exactly the same. So what I call as smart contracts, these are self-executing code that I should say automate the agreement. Okay, agreement between the two parties, and this is on sole discretion. So written mostly in Solidity. I hope you heard about Solidity. Okay, and they are deployed on a chain base, and they are immutable once they live. Okay, so that is what we have an idea about these smart contracts. And say for example, if there is a bug, okay, it becomes a permanent unexploitable feature in smart contract. That is why there is a security concern related to this also. Okay, so we cannot think कि हम blockchain use कर रहे हैं तो everything is actually secure. No, you have to align with the security standards in any domain that you work, be it be blockchain, be it be the machine learning. समझ में आया इतना? Third चीज लिखा है gas and transactions. So first of all, what is a transaction? See, transaction is every operation that we do. Okay, like sending the ETH, deploying a contract, calling a function is basically a transaction which is signed by a private key. हर transaction किससे sign होगा? Private key से. ठीक है? That is why it becomes important. What is gas? See, every transaction that we do consumes what? Computational measures. Okay, which we measure as gas. Okay. जो भी हम काम करेंगे, whatever that we evaluate, whatever that we transact on an Ethereum or a blockchain, it has to be evaluated based on gas. Okay. So what attacker do? So the attackers sometimes manipulate, okay, the gas prices, or they create something what I call, this is a terminology, spam transactions. I hope you have heard. Spam transactions क्या हैं? They try to congest the network. तो वो spamming करते हैं. आपने DOS effect सुना होगा. Similarly, we have a specific effect on this. We create spam transactions on that. Okay, so this is what you have to actually read before you go and deep dive into the Ethereum security. Okay, so there is an entire picture that you can actually read कि आपका user क्या है, user के बाद आपका transaction pool क्या है, who is the validator of that specific person, तब block बनेगा, and then you go to the blockchain explorer. This is how we actually go. तो यहाँ पे थोड़ा सा आपको ये देखना पड़ेगा जब भी आप पढ़ेंगे ऐसा कोई सब्जेक्ट लेते हैं. Probably you might have taken also. Now I will just quickly tell you what recent security incidents about. ठीक है, आपने नाम सुने भी हो सकते हैं. Let's see in case if you want to explore it more. So see what happens. Ethereum has been both innovation and exploitation. आज की डेट पे innovation मतलब है कि हमने health care sector में भी use कर रहे हैं. We are using in the land revenue record systems. Obviously, IIT Kanpur has a project with multiple organizations, and we have a national blockchain project since 2017, and we are doing it. And there are a lot of startups also who are working with us. So there are recent security attacks that we have seen. DAO attack or a DAO hack was in 2016. एक बार जाके आप पढ़िएगा. So this is one of the Ethereum's earliest and largest hack that had happened. So DAO का मतलब कोई बताएगा? This is a decentralized autonomous organization. That is what we call as DAO. DAO. Okay. So it's a smart contract fund meant to automate the investments. तो ऐसा उन्होंने कुछ बनाया हुआ था. अब इसमें vulnerability क्या है? कोई बता सकता है? What exactly could be the vulnerability? DAO attacks के लिए what can be the vulnerability or a bug that you can understand? So इसमें attacker ने क्या किया था? What attacker has done? They repeatedly call the withdraw function before the balance gets updated. ठीक है, बार बार वो withdraw function update कर रहा था या call कर रहा था, तब तक automatically balance क्या होता था? Update हो जाता था. तो आपके पास फिर से transaction हो रहा था. तो इसकी वजह से impact क्या था? That there was $60 million that has been stolen. That means billions of dollars has been actually gone out of the transaction. और result क्या हुआ? So Ethereum blockchain, they have hard forked it. Hard fork का मतलब समझते हैं? Creating ETH and Ethereum Classic. तो उन्होंने इसको break down किया. अगर आप कभी जाके इसकी study करो, so they have break down into ETH and Ethereum Classic. तो आपको ये थोड़ा सा देखने को मिलेगा कि DAO attack that was done in 2016 was the largest hack that has been done. Phishing कैसे हो सकता है? कुछ idea? What exactly the phishing in a blockchain perspective that can be done? Any thoughts on this? Phishing तो आप बहुत commonly सुनते हो, but in a blockchain architecture, how this could be done? See, blockchain तो बहुत आप बोलेंगे कि sir this is pretty much safe, but how this is relatable? What happens? See, phishing में क्या होता है? Users are basically tricked to click. यही होता है. तो ब्लॉकचेन में क्या होगा? सो यूजर्स आर बेसिकली ट्रिक टू कनेक्टिंग वॉलेट्स को हम बेसिकली क्या करते हैं, स्पूफ करते हैं, और हम बोलते हैं कि यूजर्स को बेसिकली वी वांट टू ट्रिक इनटू कनेक्टिंग वॉलेट्स टू फेक वॉलेट्स। सो फेक डेफी जो आपकी डिसेंट्रलाइज फाइनेंस मशीन्स हैं वहां तक लेके जाना है, और वी आस्क देम टू साइन द मलिशियस स्मार्ट कॉन्ट्रैक्ट्स। ठीक है, तो उससे होगा क्या? अटैकर विल ट्राई टू ड्रेन फंड्स इंस्टेंटली। ठीक है, और तीसरी चीज क्या पॉसिबल है कि फिशिंग विल टारगेट समथिंग वेरी इंपॉर्टेंट यूजर्स विच आर वेरी क्रिटिकल। आई डोंट नो इफ यू हैव हर्ड, देयर इज मेटामास्क करके एक है पूरा। ठीक है, किसी ने सुना है? अरे वंडरफुल। सो देयर इज मेटामास्क, और कोई नाम बता सकते हो आप? ओपन सी। Okay, so you should look for this. So phishing kits target basically MetaMask or OpenSea kind of users. So why? Because see, this will highlight the social engineering factor that is added. क्योंकि मेरे को तुम्हें social engineering का मतलब क्या है? I need to actually make a specific user to get drained. तो मेरे को पहले उसको वहां तक लेके जाना पड़ेगा. I will ask them to click something or to redirect something to a fake account. So यहाँ fake accounts तो है नहीं. What do we have? We have fake wallets. We have fake DeFi. The decentralized financing systems, तो वहां तक वो जाएगा, and then the exploit actually happens. So ये आपको इसमें एक बार देखने को मिलेगा फिशिंग में. I don't know if you have heard about MEV, the minor executable value. Now we have a maximal extractable value also. Okay, so not executable, this is an extractable value. सुना है इसके बारे में कभी? So it's not a traditional hack, but it's an economic exploitation of Ethereum architecture. इसको आप पढ़िएगा एक बार. You will get to know. I will share the slides in case if it is needed. See, miners or validator. Miner तो समझते हो आप, who adds the blocks basically. Miners और validator क्या करते हैं? They can reorder, they can insert, or they can censor transactions to profit. ठीक है, हम ये काम कर सकते हैं. So there are certain examples that you can read. Like there was a sandwich attack that happened in the decentralized finance of trading. So वहाँ पे फ्रंट रनिंग और बैक रनिंग जो यूजर थे उनको बेसिकली हमने एक्सप्लॉइट किया था. ठीक है, सो देयर वर लाइक लॉट ऑफ लॉसेस, हंड्रेड ऑफ मिलियंस हैज बीन गॉन, एंड दिस विल बेसिकली हेल्प यू टू अंडरस्टैंड द एंटायर मैथमेटिकल रीजनिंग दैट इज बेसिकली यूज्ड इन दिस. तो उसमें एक फैक्टर यूज करते हैं, वी कॉल एज गेम थ्योरेटिक अप्रोच. ओके, आई डोंट नो इफ यू हैव हर्ड, सो वी कॉल इट एज गेम थ्योरी. सो गेम थ्योरेटिक मैनिपुलेशन हैज बीन डन. सो दिस इज व्हाट बेसिकली वी कॉल एज MEVs. ये recent incidents जो हुए हैं, probably I don't know the exact date or year, but ये अभी 23 में और 24 में you will fall out. और last is smart contract exploits. ये तो बहुत सारे हैं. कोई recent का example if you can suggest or not? नहीं? Any thoughts on this? इसमें करते क्या होंगे? Smart contracts exploits के लिए. What do you have? See, we borrow large amount of sums instantly. बहुत सारे large sum हम borrow करते हैं. We manipulate the token prices and then we drain the liquidity, okay, from the entire chain to repay the loan. So what happens? Everything is done in one transaction. That is why it becomes more of the dispute and it becomes an incident or a bug. So ये थोड़ा सा तुम्हें देखना पड़ेगा, because this is basically what is going on in Ethereum. आप implement तो बहुत लोग कर रहे हैं. Right, see, manipulation is basically not only done at the block level. Obviously, you have to actually do the manipulation at different levels, because in case if it reaches to the block level, it has to be basically done in a closed chain and everybody should get to know about this. But see, what happens in major of the cases, like अगर आप इसका पढ़ोगे smart contract exploit का, so there are flash loan attacks. We call it as flash loans. So borrower क्या करता है, बहुत सारा sum एक साथ निकालता है instantly. ठीक है, उससे होता क्या है? So they basically try to manipulate the token prices. तो वो पूरे चेन में आपको नहीं दिखाई देगा. ठीक है, and then they try to drain the liquid money, which is obviously a legitimate thing that could happen. और फिर उससे वो रीपे करता है लोन. So repaying of the loan is obviously a legitimate case. But अगर ये सब कुछ एक ही ट्रांजेक्शन में हो रहा है, then it becomes a kind of an exploit that happened. Yes. Okay, so I hope at least you got some idea, and last but not the least is why Ethereum that we are trying to use and why ML. ठीक है, so the reason to this, that why are we focusing majorly on Ethereum? Why? Any idea? This is most active. There are other platforms also apart from Ethereum, but this is most active. And second thing is data rich, what I call as data rich. जब तक डेटा नहीं होगा I cannot go to application of ML. Third thing is this Ethereum is basically a programmable kind of a blockchain ecosystem. Programmable मतलब जहां पे तुम चीजों को induce कर सकते हो, ठीक है. And now you have to understand कि Ethereum में बहुत सारा process होता है, millions of transactions daily होते हैं, ठीक है. That is what you have to understand. Okay, so Ethereum basically processes billions of data across whatever the networks that we have, and it's a public ledger. I hope you understand the public ledger. Public ledger means, right, and it provides enormous amount of structured data. बहुत important है हमें ML लगाने के लिए structured data मिलना जरूरी है, for which machine learning analysis can be performed. अगर structure नहीं होगा, you have to take another pain to make it a structured data. Okay, and also one more important thing that advantage Ethereum has, इसका scaling unit बहुत है. It has a sheer scale. आप कितना भी scale करना चाहो, you can do that. And yes, जो इसका drawback तो नहीं कहूँगा, it is more complex. The complexity of transactions and everything makes it like possible that where people are using Ethereum a lot. But yes, that's where machine learning fits in. Okay, because it will help you to detect all over the anomalies, security incidents, fraud, suspicious, whatever the factors that you have. Okay, so this is what you have to understand. Let's move on to the next part that I have. Okay, we'll quickly, concisely kept it. Okay, so these are the threat categories. ये थोड़ा सा तुम्हें समझना पड़ेगा before you dive into the research part of this. मैंने line 3 ही लिखी है, but this is an entire subject with us. Okay. So see, the purpose of this is that you have to basically focus on a specific threat categories. So what those categories are? So I have written 3 categories out of this. The first category you should read is a smart contract vulnerability, which is very, very important. Why? Because smart contracts are the programmable backbone of Ethereum, and they are powerful, but they are unforgiving. Why? Because once you deploy it, their code becomes immutable. The code is already immutable, so if there is a bug, say for example, it becomes a permanent attack surface. ये बहुत important है. अगर bug आ गया है और आप बोलते हो कि immutable है, so it will reside there. So इसमें कुछ categories हैं. So I have actually written these 3 categories, and my request is, if you go back and if you're doing some research into blockchain, you should learn about the re-entrancy attack. किसी ने सुना है पहले? See, this kind of an attack occurs when a contract calls an external contract, okay, before updating its own state. So what happens in this case? The external contract can then call back into a vulnerable function, okay, और वो बार बार कर सकता है, और अगर वो बार बार करेगा तो क्या होगा? It will drain out the funds, और वो iteratively करते हैं इसको, ठीक है. And the famous example was what that I have actually told you, the DAO attack in 2016. Over there the same phenomenon was used, okay, and where the attacker exploited the re-entrancy bug in the DAO's withdrawal function. वहाँ पे वो withdrawal function था, उसको बार बार drain कर रहे थे, and उसमें हो क्या रहा था? Before the balance update executed, they repeatedly called the same function, and millions of things has been actually lost. अब मेरा क्वेश्चन आपसे ये है, इसमें ML कैसे लगाओगे अगर मेरे को ये पकड़ना है, the re-entrancy attack? ये आपको सोचना है जाके. You have to actually apply ML. You find the ML relevance into this. तो पहला फीचर क्या है? You need to think about the repeated, you need to think about the recursive transaction patterns with similar timestamps and identify destination addresses which are showing some sort of temporal anomalies. I hope you understand this. These are the features that we use in machine learning which can flag that there is an anomaly. I hope you understand. मैं फिर से repeat कर सकता हूँ. देखो, DAO attack में कुछ चीजें repeatedly हो रही थी. So हमें find out करना है, we need to find out the repeated recursive transaction patterns. That is very important. Why? Because they may have the similar timestamp, they might be having the identical destination address, and they may show some sort of anomalies, the temporal anomalies. That may be the features that your machine learning algorithm might be having. So ये relevance आपको निकालना पड़ेगा re-entrancy के साथ. Second, अगर आप देखो, so I have a specific category known as overflow. Overflow can be integer overflow, it can be underflow also. What does it mean? See, ये कब होता है? It happens when your numeric operations exceed or fall below the storage limit. भाई तुम्हें C programming use कर रहे हो, so you have an integer, obviously you can hold specific value, ठीक है? So if you exceed or fall below the storage limits, you will be under overflow or the underflow or the overflow. But इसको use कैसे कर रहे हैं? See, attacker manipulates the balances or the token supply. And you probably might have seen some examples. You should write. There is an example named as batch overflow that happened in 2018. So this is a vulnerability which allowed the attackers to generate arbitrary tokens. 2018 का एक केस था which we call as batch overflow, जहाँ पे ये देखने को मिला. But now again the question comes, how do you actually apply machine learning to implement and find the vulnerabilities related to overflow? क्या चाहिए होगा आपको? Whenever these kind of transaction happens, there are certain spikes, ठीक है? So आपको spikes निकालना है. So we need to find those abrupt spikes in token mining or value transfers that can appear as outlier patterns. Outlier, you understand? Outlier कहाँ पे लगाते हो? You work on outliers in the case of unsupervised learning. Okay, not in supervised. We have to go into unsupervised part. ठीक है? Third is logic bugs. I will quickly sum up this because I have less amount of time. See, logic और एक होता है authorization bug. क्या होता है? Authorization. What do you understand by this? See, these are the mistakes that we do in access controls, we do in condition checks or the business logic. So that is what is categorized as logic bugs. और इसका बहुत अच्छा example है. In 2017 there was a hack or a specific case named as parity multisig wallet hack. Parity multisig wallet hack, आप उसको देखिएगा. The wallet's initialization function could be called by anyone. ठीक है, उसमें उन्होंने जो function use किया था, the wallet's initialization function, वो कौन call कर सकता है? The maker of the node specifically. But वो कोई भी call कर रहा था. And what happens in that case? The attacker can reset the ownership. वो नहीं होना चाहिए था. Obviously, if I am specifically the owner, I have an access, I have a privilege to that. I should not be able to do that. And they have actually took controls of the funds and millions are basically hacked. अब फिर ये तो blockchain का part हो गया. अब ML कहाँ लगाएंगे और कैसे, क्या चाहिए? See, I need to use my charger. Thank you. So machine learning कहाँ पे लग सकती है? See, sudden unauthorized ownership transactions अगर हो रहे हैं, so you will be able to make out. If there are new admin keys that can create structural anomalies, you will be able to find it out. इसके लिए ज़्यादातर हम graph analysis use करते हैं. So we have to actually move ahead from unsupervised learning to graph based algorithms. So there has to be a threat type. Threat type is reentrancy, overflow and logic bugs. But आपको देखना है कि उसका impact क्या है. First impact is the theft that you could do. Overflow अगर हो रहा है, so it can actually lead to token inflation. और अगर logic bugs हो रहे हैं, so it is an asset lock or theft about that. ठीक है, और बहुत सारे ऐसे examples आपको मिलेंगे. So this is an entire subject actually. तो ये जो तुमको एक लाइन में लिखा है ना, ये पूरा एक subject है. इसको आपको time देना पड़ेगा. There are multiple papers also if you want to read it. Second is transactional anomalies. What does it mean? See, not every attack that we see is a code exploit. Okay, many may involve what I can say as manipulated financial behaviors on the chain that we see actually. और इसका बहुत अच्छा example है wash trading. कभी सुना है? Wash trading. What does it mean? See, this wash trading occurs when an entity buys, or I should say they sell to the same token. Okay, they are trying to buy and sell to the same token or to itself or to the coordinated values. Why? Basically, they are trying to create a fake volume. आपको fake volume बढ़ाना है, ठीक है? तो आप क्या करते हो? You do a random scaling. So you basically buy and sell whatever the same kind of tokens that we have. And where we see, they are very, very famous on platforms like DEX. DEX एक platform है, and there are NFT markets also. Okay, तो वहाँ पे आपको ये बहुत आराम से मिलेगा. और इसके लिए भी वी आर एक्चुअली ट्राइंग टू अप्लाई सम सॉर्ट ऑफ मशीन लर्निंग एल्गोरिदम. व्हाई? बिकॉज सी, जब मल्टीपल ट्रांजेक्शंस होते हैं between the same wallet pairs within a very short interval time with no real net transfer of value, you have a pattern. जैसे आपने DOS सुना है ना, DOS denial of service, उसका पैटर्न आइडेंटिफाई कैसे करते हो आप? Is there any pattern that I want to identify? एक सोर्स से there are multiple, sorry, एक specific source, it is trying to actually hit a specific IP address within your boundary. Okay, तो you identify through the Wireshark kind of a tool, और T-Shark आप यूज करते हैं, पैकेट कैप्चर्स पे we do the analysis. So we are able to make out that pattern. उसको हम मशीन लर्निंग में फ्यूज कर सकते हैं because we have a standard rule to set. Okay, तो रूल बेस्ड अप्रोच भी है, but we have a machine learning based approach. If this is denial of service, this is a denial, distributed denial of service. If we have a sync flood attack, and there is a long category. Similarly, you have to do in the wash trading also. क्योंकि multiple transactions है, but they are trying to follow a single pattern. क्या पैटर्न है? Transactions are between the same wallet pairs. You know the pair actually, and within a very short interval of time. So आप threshold लगा सकते हो, and there is no real net value जो कि ट्रांसफर करी गई है. तो आपके पास पता है कि गैस प्राइस कितना है, कितना आपके पास टोकन प्राइस है. So you will be able to know that. Second category of transaction anomalies that you should read is Ponzi schemes. Any idea on Ponzi schemes? ये तो बहुत कॉमन वर्ड है ब्लॉकचेन के लिए. मेरे को लगता है कि आप बता पाएंगे. कभी नहीं सुना Ponzi? And there is one more word is what I heard is Ponzi and pyramid schemes. Ponzi और pyramid schemes होती हैं, नहीं सुना? चलिए, see, smart contracts, they promise us high returns. Okay, why? Because they involve into paying older investors using funds from new ones. That is what actually happens. But आपको इसमें ध्यान रखना होगा, in 2020 there is a specific study under the name of Forsage, F-O-R-S-A-G-E. You should read about this. This is multi-level smart contract Ponzi with over of millions losses. उसमें हुआ क्या था? What exactly was happened? There was large inflows. There was large inflows followed by no legitimate outflows. आने वाला तो बहुत सारा कुछ था, but हमने कोई भी transaction out the bound नहीं किया. So what exactly could be the features? So there are hierarchical features and hierarchical address relationships जो आप निकाल सकते हो. भाई मैंने आपको एड्रेस पे कुछ किया ट्रांजेक्शन, somebody else has done, so there is a large inflow, but obviously we are not able to make out any of the outflow in that case, legitimate. तो इसमें क्या अप्रोच यूज करोगे मशीन लर्निंग के लिए? That is what you have to identify. So there is a clustered graph structure that you can actually build to detect the flow of upward repeatedly. ठीक है, और ये ग्राफ से इजीली निकल आएगा, आप सुपरवाइज लर्निंग में नहीं निकाल पाएंगे. दैट इज वाई मैंने पहली वाली स्लाइड में आपको बोला था, ब्लॉकचेन के सारी चीजें आपको रिलेट करनी है वेयर यू कैन एक्चुअली यूज मशीन लर्निंग. ठीक है, आप जबरदस्ती नहीं कर सकते कि हमें एमएल का यही पार्ट लगाना है, प्रॉब्ली हो सकता है वो ना लग पाए. सो यू हैव टू आइडेंटिफाई द बिहेवियर फर्स्ट, कि उसका बिहेवियर क्या है, एंड वंस यू हैव अ बिहेवियर यू नीड टू आइडेंटिफाई द पैटर्न. एंड इफ देयर इज अ पैटर्न, इथेरियम क्यों चूज किया? Because Ethereum is the real blockchain application which has a huge real data, और वो बढ़ता ही जा रहा है. So that is why data का कोई कमी नहीं है, but obviously we need to identify which specific thing that we can apply. And last is money laundering and mixing. So criminal they use a lot of mixers. Mixers सुने? Tornado Cash ये करके बहुत कॉमन नाम है जो डार्क वेब पे चलता है. ठीक है, so we use Tornado Cash for that. और we use split transactions across thousands of small wallets. ठीक है, तो मनी लॉन्ड्रिंग हमारे यहाँ पहले हवाला के थ्रू होती थी. ठीक है, अभी भी हो रही है, but people are trying to actually use this also, and the aim is to obfuscate the origin of funds. Obfuscation मतलब मैं उसको चेंज कर दूंगा so that it becomes very difficult to actually detect. ठीक है, आपको उसको डिफिकल्टी, obfuscation का मतलब आप सोच लो we add some sort of instructions to it. और चैलेंज क्या बन जाएगा? बिकॉज ट्रेसेबिलिटी बिकम्स अ चैलेंज. अब रीजन इज इफ यू आर अप्लाइंग सम सॉर्ट ऑफ मशीन लर्निंग ऑन मनी लॉन्ड्रिंग, तो डेटा सेट कैसा चाहिए? डू यू आइडेंटिफाई द डेटा सेट? तो डेटा सेट में आपको फाइंड आउट करना पड़ेगा. फिर वहीं पे फिर वही क्वेश्चन आ जाएगा कि फीचर इंजीनियरिंग में क्या लें और बिहेवियर कैसा लें. तो दैट इज अप टू यू हाउ यू आइडेंटिफाई. बट मेरे हिसाब से हमने 3 कैटेगरीज रखी थी. एंड लास्ट कैटेगरी इज दैट आई जस्ट क्विकली वांट टू टेल इज नेटवर्क लेवल थ्रेट्स. पहला तो स्मार्ट कॉन्ट्रैक्ट की वनरेबिलिटी. आई होप यू अंडरस्टैंड दिस वर्ड, जो थोड़ा सा रिलेट कर पा रहा है. सी आई एम नॉट एक्चुअली ट्राई टू केटर कि आपको ब्लॉकचेन का आइडिया नहीं है, ये तभी समझ में आएगा जब थोड़ा सा आइडिया, ठीक है। ट्रांजेक्शन इज क्लियर, नेटवर्क लेवल क्या हो सकता है, एनी थॉट्स ऑन दिस? See, beyond the smart contracts and the transactions, Ethereum has a network layer and it also faces a lot of risk. Why? Because these are attacks on the blockchain's peer-to-peer structure and as well as on the consensus behavior that it holds. तो ये वहां पे है, ये network layer पे है, आप application layer से बाहर आ गए हो. And there are few examples. One is Sybil. Sybil is basically what happens. The attacker creates multiple fake identities like nodes. ठीक है, इस केस में ऐसा है. Why? To influence reputation or the network control. आपने बहुत सारा fake nodes बना दिया, obviously the bandwidth goes down and there will be multiple other things. And ये तुमने commonly देखा होगा voting systems के लिए, ठीक है, और where we have to do the validation process. So इसमें हम ML बहुत easily लगा सकते हैं. I will tell you the reason. We have abnormal peer creations. Peer का मतलब peer to peer network का कोई example दे सकते हो? If there is an example for peer-to-peer network or application that you use. पहले आप बहुत यूज करते थे डाउनलोड करने के लिए कुछ. That is a peer-to-peer network that we use. Torrent. Torrent is a specific example of a peer-to-peer network. When we download, it searches for among the peers. कौन सी फाइल कहाँ से मिल रही है, पहले आपको वो डाउनलोड कराई जाएगी, ठीक है. तो अभी भी यही चल रहा है. So basically you have to understand कि वहां पे ML कैसे लगेगी. तो हम एबनॉर्मल पीयर कनेक्शंस को निकालते हैं एंड देन वी डिसाइड द पैटर्न. सो अभी थोड़ा सा थ्योरेटिकल लग रहा है, बट सी एप्लीकेशंस ऑलरेडी देयर और वो एग्जिस्ट कर रही हैं. एंड सिमिलरली वी हैव एन एक्लिप्स एंड डबल स्पेंडिंग काइंड ऑफ थिंग. डबल स्पेंडिंग क्या है? ये बहुत कॉमन टर्म है, राइट? एग्जैक्टली. टू कॉन्फ्लिक्टिंग ट्रांजेक्शंस यूजिंग द सेम फंड्स, it gets broadcasted to different parts of the network and through rare on they are specifically rare on the Ethereum mainnet. So but हम उसको अभी भी आइडेंटिफाई कर रहे हैं. मेन नेटवर्क पे आपको नहीं मिलेगा, बट दे कैन अकर ऑन दी फोक्ड नेटवर्क और दी टेस्ट नेट्स, ठीक है. तो वहां पे तुम्हें आइडेंटिफाई करना पड़ेगा, ठीक है. सो दिस इज वन पार्ट एंड लेट्स क्विकली शो यू द डेटा सेट दैट वी हैव. This is what we actually use in the ML part. In case if you want to check, so see, supervised machine learning, we have unsupervised graph based, and then there are some feature engineering approaches that I actually use specifically onto this part. So ये थोड़ा सा मैं आपको इसके बारे में हल्का सा एक hint दे देता हूँ, so that at least you have an idea where to use what and not. Supervised is clear. So we have a labeled data set. Okay, labeled means that you have transactions, you have addresses that are known to be fraudulent or legitimate, ठीक है. So input will be what? Input will be the historical data with labels. Fraud अगर है तो 1, normal है अगर तो 0, ठीक है. And the goal is basically to train a model to predict whether a transaction is likely fraudulent. इसके लिए आपको करना क्या पड़ेगा? हमने एग्जाम्पल मॉडल तो लिख दिया है, बट चाहिए क्या होगा? You need a simple baseline. Baseline का मतलब समझते हैं? At least there should be a model or a data set that you have as a trained model. You have to collect the data, you have to label that data, you have to extract the features. Features बहुत सारे हो सकते हैं. Then you train the classifier and then finally you predict and evaluate. यही शायद आप supervised ML में करते होगे. I hope in case if you have done this, तो इस तरह से चलेगा. Unsupervised model कैसे चलता है? See, unsupervised does not rely on labels. Labels आपके पास नहीं है. अनसुपरवाइज्ड अगर नहीं है तो दैट मीन्स यू वर्क ऑन अनयूजुअल बिहेवियर. जैसे मैंने पहले भी बताया था, इन इथीरियम एनॉमलीज कुड बी. आप सोच सकते हो कि एक वॉलेट है, सडनली स्टार्ट सेंडिंग 500 स्मॉल वैल्यू ट्रांजेक्शंस इन अ मिनट, ठीक है. देयर कुड बी अ कॉन्ट्रैक्ट दैट सडनली स्टार्ट्स इंटरैक्टिंग विद हंड्रेड्स ऑफ अननोन एड्रेसेस. तो ऐसा भी हो सकता है, ठीक है. देयर आर सडन स्पाइक्स इन द गैस यूजेज. तो ये सारे के लेबल डेटा मिसिंग है. आपको उसको कैसे करना पड़ेगा? आउटलायर के बेसिस पे, ठीक है. सो यू नीड टू डिटेक्ट द एबनॉर्मल ट्रांजैक्शन एक्टिविटी वेयर योर अनसुपरवाइज्ड मॉडल्स विल फिट इन. ओके, और कुछ एग्जाम्पल मॉडल्स मैंने लिखे हैं, लाइक आई डोंट नो इफ यू हैव हर्ड अबाउट दिस. इसमें आप अनसुपरवाइज्ड में ऑटो एनकोडर्स का यूज कर सकते हो. डू यू नो व्हाट एन ऑटो एनकोडर इज? बेसिकली राइट फॉर द कंसेप्ट ऑफ विजुअलाइजेशन. सी, नॉर्मल अगर ट्रांजैक्शन है सो इट्स लो रिकंस्ट्रक्शन एरर, तो आपको ऑटो एनकोडर्स को फाइंड आउट करना पड़ेगा. and then you have to apply it. So but see, अभी के लिए मैं over the above एक आपको feature दे रहा हूँ, so that at least you can understand this. Graph based learning, you understand? See, graph based में क्या है? Ethereum data is basically or naturally graph structured. ऐसा सुना है आपने? See, so this is entirely graph structured data that we have. So every address interacts with the other through transactions. Okay, I hope this you understand. Graph based में फिर से एक बार repeat कर दे रहा हूँ. See, graph based का मतलब है we are using Ethereum. So Ethereum data is naturally graph structured. Why? Because every address interacts with the others through transactions only, and that is what we have seen today. And this graph structure, I should say, carries something what we call as valuable patterns. Valuable pattern में क्या आएगा? हमारे पास relationships हैं, we have behavioral similarity जो आपको चाहिए. Now how Ethereum becomes a graph? ये क्वेश्चन है. तो आप कैसे बनाओगे उसका ग्राफ? You need nodes. Nodes चाहिए. So what are nodes? These are all the wallet addresses or contracts that we use. Second चीज क्या चाहिए? You need the edges. Edges will be the transactions between them. Third will be the edge attributes. Attributes में क्या चाहिए? You need gas used, the ETH that is used. You need the timestamp. You need the function call. ये सब आपको edge के attributes में मिलेगा. And last but not the least, we have a node attribute also. Node attributes कभी सोचे हैं आपने? Account का type क्या है? वो EO है, वो contracts हैं, total value कितनी transfer करी गई है, transaction count कितना है, तो ये सब आपको उसमें मिलेगा. So we use GNNs, what we call as graph neural networks for this. Okay, so you should go back and some point of time people who are doing into blockchain can see about this. So GNN क्या करता है? So GNN basically try to learn both the node features and as well as the graph topology जो आप उसको देते हो. Meaning they understand how the accounts are connected and they behave in the context जो आपने उसको बताया. ठीक है. So basic working क्या है कि हर एक node, each node starts with its own feature. Feature मैंने बता दिए, transaction की frequency, the gas usage that you have. Second thing, if the model has to aggregate the information from the neighboring nodes, तभी वो connected addresses में आएगा. Otherwise, it will not do that. And third is, you have to iteratively update the node representations. Why? Because हमारा main goal क्या था? To detect the suspicious accounts. तो वो तभी कर पाओगे. And why GNNs we prefer for what I should say as blockchain? So we can detect the fraud rings like the groups of addresses working together. ठीक है? या आप ये भी सोच सकते हो कि flow of funds अगर आपको निकालना है, so you can capture the flow of funds across multiple hops through this graph network. So this is possible. And even you can identify the Ponzi or laundering networks that are working in India. Not India, but specifically around the globe, using structural similarity using the GNN. So GNN का बहुत applicability है. अभी के लिए आपको थोड़ा सा इसको देखना पड़ेगा कि आप कैसे implement करोगे. So data and everything will be needed. And last but not the least, feature engineering is very very important. तो data set तो अभी मैं बता दूंगा कि कौन सा specific कुछ examples हैं that I have placed on the next slide. But feature engineering approaches are important. Like transaction frequency की अगर बात करते हैं, so example features क्या हो सकते हैं? So we have average transaction value, या आपने कितना गैस यूज किया है, so ये मेरे ट्रांजेक्शन बेस्ड फीचर है. और अगर मैं अकाउंट बेस्ड फीचर की बात करूं, देन वी हैव स्पेसिफिकली अदर फीचर्स लाइक अकाउंट का एज कितना है, वी कैन हैव ग्राफ बेस्ड फीचर्स, वी कैन हैव कॉन्ट्रैक्ट बेस्ड फीचर्स आल्सो. तो थोड़ा सा रिसर्च पेपर्स को आपको फाइंड आउट करना पड़ेगा फ्रॉम बेस्ट ऑफ द बेस्ट जर्नल्स दैट वी हैव एंड द प्रोफेसर, देन ओनली यू विल बी एबल टू मेक बेस्ट ऑफ द फीचरिंग अप्रोचेस. ठीक है. एक इसमें इंपॉर्टेंट पार्ट है, मैं आपको फिर से बता देता हूँ. देखिए, जब फीचर्स निकालेंगे, जैसे मान लो मैंने आपको बोला एक फीचर निकालिए डिग्री सेंट्रलिटी करके एक फीचर होता है विच विल स्पेसिफिकली मेजर हाउ अ कनेक्टेड नोड यहाँ पे मेरा वॉलेट है इज इन द ट्रांजेक्शन ग्राफ. सो हमें किस तरह से वो कनेक्टेड है वो निकालना है. तो उसका एक हाई डिग्री का स्पेसिफिक वैल्यू है, मतलब कि वो एक्टिव नोड है या नहीं. ठीक है, वो एक्सचेंजेस कर रहा है या नहीं, इज देयर एनी सडन इंक्रीज इन द डिग्री और नॉट, तो वो तुम्हें निकालने पड़ेंगे. So मेरा पॉइंट ये है, there are fundamental features and there are derived features, और what you call as in our machine learning language is the synthetic features. आपको कुछ features derive करने पड़ेंगे standard से, but वो तभी आ पाएगा when you actually do an intrinsic research on that. और एक चीज और याद रखिएगा, थोड़ा सा APIs पे काम करेंगे तो आपको मिलेगा कि बहुत सारी इथेरियम की APIs हैं which can help you out in this case to actually do a lot of other stuff. ठीक है, so I will quickly move on to the next slide to end this particular process because I know you are having your other things to do. So ये कुछ possible data sets मैंने लिखे हैं and experimental insights possibly. So ये डेटा सेट्स आपको वैसे भी मिल जाएंगे, सी दीज आर ओपन सोर्स डेटा सेट्स, ठीक है, और कुछ APIs भी मैंने लिखी लाइक EtherScan API. So EtherScan is obviously the most popular Ethereum blockchain explorer and it provides a REST API for developers and researchers, so you can use it. And what you can access from it, see it gives you the transaction details like sender कौन है, receiver क्या है, value क्या है, gas क्या है, timestamp क्या है. You can actually have something what I call as contract source code and the APIs for that. इंटरनल ट्रांजेक्शन्स के बारे में, टोकन के ट्रांजेक्शन्स, एवरीथिंग यू गेट दैट. किसी ने यूज किया पहले है? आपने किया, वंडरफुल. तो दिस इज अ नोन स्पेसिफिक API दैट यू विल गेट, और उसका एक पाइथन आपको स्निपेट भी मिल जाएगा कि किस तरह से आप API को इंटीग्रेट करो. तो उसमें API की आपको डालना पड़ेगा एंड देन यू कैन एक्चुअली कॉल इट अपॉन. ओके, सो दिस इज व्हाट यू कैन डू. व्हाई? सी इट विल एक्चुअली हेल्प यू एनेबल बिल्डिंग ट्रांजेक्शन लेवल फीचर्स जो हमें चाहिए, like average gas क्या है, inter transaction intervals क्या है, and the people who can actually understand this can relate that this is very important. उस साइट पे मैंने एक लिखा Ethereum blockchain ETL which is Google BigQuery. ठीक है, so Google BigQuery क्या है? That's host a public blockchain data set. कभी आप find करना including Ethereum and that are indexed and they are queryable using SQL. आप query कर सकते हो. So उसका data set का नाम मेरे को नहीं याद आ रहा, तो एग्जैक्टली ऐसे करके कुछ है, बिग क्वेरी पब्लिक डॉट डेटा समथिंग, सो यू कैन एक्चुअली सर्च विद दिस नेम एंड यू विल बी एबल टू गेट. तो उसमें मिलेगा क्या आपको? वी हैव ब्लॉक टेबल्स. ब्लॉक टेबल्स का मतलब कि ब्लॉक हेडर्स, टाइम स्टैम्प्स, माइनर की इंफॉर्मेशन व्हाट वी नीड वो है. ट्रांजेक्शन टेबल भी है, कॉन्ट्रैक्ट टेबल भी है, सो यू शुड गो बैक एंड सी. और बहुत इंपॉर्टेंट आज की डेट पे हमें कभी लॉग टेबल चाहिए होता, ठीक है, सो वी हैव अ लॉग टेबल ऑल्सो विच इज प्रेजेंट हियर. ऐसे इलेप्टिक 2 डेटा सेट है, पीपल हु ट्राई टू गो इनटू द बिटकॉइन पार्ट ऑफ द एंटायर स्टफ. सो व्हाइल बिटकॉइन बेस्ड द डेटा सेट इज ऑफन यूज्ड conceptually for Ethereum because it provides growth truth labels, okay, like for illicit and as well illegitimate transactions. तो ये थोड़ा देखना पड़ेगा क्योंकि इसमें डेटा कंसाइज है, बहुत ज्यादा नहीं दिया because they do not actually publish it, but है अच्छा खासा. If I hope remember करीब 2 लाख ट्रांजेक्शंस के आसपास बिटकॉइन की आपको मिल जाएंगी एंड देयर आर 166 डायमेंशनल फीचर उन्होंने यूज किए हैं. तो एटलीस्ट आपकी स्टडी के लिए काफी है. इट्स इनफ फॉर एक्चुअली द स्टडी सो दैट आप फोकस कर पाओ आगे क्या करना है. EtherScan DB, Xblog, Ethereum data sets are also there. So this is maintained by an organization named as MyCrypto. Okay, they aggregate the verified scams जो आजकल हो रहे हैं उसी का डेटा, ठीक है. एंड जैसे अभी हम डिस्कस कर रहे थे, वी हैव फिशिंग एड्रेसेस ऑल्सो, तो आपको उसका डेटा यहाँ पे मिलेगा. और डेटा में अच्छी तरह से अगर आप देखोगे जो यू विल गेट जो कि स्कैन URLs थे, जो लिंक्ड इथीरियम हमारे एड्रेसेस थे, द टाइप ऑफ स्कैम दे कैटेगराइज की फिशिंग है, गिव अवे है, फेक ISO है, सो ऑल ऑफ दैट इज देयर, ठीक है. तो थोड़ा सा आपके लिए ज्यादा हेल्पफुल है इफ यू वांट टू वर्क ऑन द सिक्योरिटी एस्पेक्ट ऑफ दिस. और एक Xblog इथीरियम करके डेटा सेट है विच इज एन एकेडमिक डेटा सेट फॉर machine learning researcher in case if you want to do, people are trying to use that, but ये supervised classification में ही आपकी help करेगा, कहीं नहीं पे वो आपको देखना पड़ेगा, मैंने ध्यान नहीं दिया, I haven't used it so मैं बता नहीं सकता, but yes some of the students at our organization were using. Example findings में मैंने इसलिए बताया है कि अगर आप इसको use करते हो at least, so you will be able to actually build some machine learning models which have these kind of accuracies which is near to what I say as 95%. बट प्लीज याद रखिएगा यहाँ पे ग्राफ बेस्ड एम्बेडिंग्स ही यूज करेंगे. कई लोग XGBoost मॉडल्स का भी यूज करते हैं, तो आई एम नॉट वेरी स्पेसिफिक. यू कैन एक्चुअली कम अक्रॉस विद एन हाइब्रिड मॉडल. हाइब्रिड का मतलब समझते हैं? सो वी यूज नोड टू वेक्टर प्लस XGBoost. नोड टू वेक्टर इज अ ग्राफ एम्बेडिंग मॉडल एंड XGBoost इज अ क्लासिफायर दैट कम्स अंडर सुपरवाइज्ड कैटेगरी. बट सी द प्रॉब्लम इज दैट वी हैव टू बिल्ड अ ट्रांजेक्शन ग्राफ. Nodes will have addresses, edges will have the transactions between them, and then I will be using node to vec जो आपका क्या करता है? It's basically create a vector embeddings for each node. तो वो आपको ग्राफ रिप्रेजेंटेशन के लिए हेल्प आउट कर रहा है. सो दैट इज व्हाट यू हैव टू एक्चुअली visualize. Okay, and then somebody can train the XGBoost on labeled models also, like for fraudulent and anomaly detection or abnormal detection. तो वो भी आपका एक part है, and that is why people have actually come across 95% precision, and which is obviously like relatable also, but they depend करेगा that what exactly you are trying to cope up with. Sorry if I have missed out something. So this is the tools and frameworks, and the slide got repeated eventually, and this is last slide that I had for today. So this is basically the conclusive remarks, I should say. See, machine learning probably people are implementing on the go, कुछ भी कर रहे हैं, ठीक है, मतलब I'm not commenting on that, but before you begin you have to have a complete idea on the behavioral aspect of this. That is what I try to actually pitch in. आप कुछ भी use करने से पहले you should actually have a meaningful information. See, traditional blockchain monitoring systems based on, rely on, I should say, rule based or signature based detection, but you have to understand, like, while effective they are for the known threats, तब rule based लगेगा, but अगर आपके पास कोई signature नहीं है, then obviously you have to find the machine learning adaptability. So machine learning brings pattern based intelligence and it learns what normal blockchain behavior look like. तभी हम ML लगाने की बात कर रहे हैं. हम रूल से काम चला सकते थे, but जब behavior की बात आई, obviously I have to use this, and based on that they will help you to identify the deviations in real time. जैसे a random forest model can learn transaction characteristics of the scam wallets and can generalize to the new ones. ये आपका machine learning कर सकती है, but rule based analogies नहीं कर पाएंगे. Auto encoders लगाइए, they can continuously update its understanding, okay, of normal Ethereum क्या है, तो auto encoder आपको इसके में help करेगा. You can apply graph neural networks जैसे मैंने बताया. Why? Because they can learn how legitimate wallets are usually connected, okay, and then based on that you can actually detect new suspicious clusters and all. Ethereum obviously provide कर रहा है हमें rich data structure, that is why we are counting on Ethereum, and it's basically transparent and consistent, that is why we are using. वो तो एक fact है, but data बहुत है, otherwise बाकी blockchains जो हैं आपके पास उस पे आपको नहीं मिलेगा. That is why we are based on this, and we are counting on Ethereum actually. And lastly, graph ML and hybrid models are future for blockchain threat analytics. That is what I can say as of now. See, blockchain is just, I hope this is fine. See, blockchain data is, कोई बात नहीं, इसको बंद करो. So last but not the least, see, blockchain जो आपका data आप use कर रहे हो, see, it's inherently relational. Each wallet, smart contract and transaction that we are trying to use is connected, ठीक है, and that is why, see, blockchain is not just a log, it's a massive evolving graph, that I should say, ठीक है. तो अगर आप graph की बात करोगे, so it becomes easy as of now, क्योंकि अभी के लिए हमने काफी aspects उसके clear करे. आपके पास data assumptions हैं, you have what I show as detection का scope है. So I think that graph ML looks at a context, they are not working on individual behavior, ठीक है, that's are very crucial in fraud detection, and that is what I have as of now. But see, blockchain have lot many other applications, not only this. See, this specific FDP is obviously is a learning scope that you have, but my point is that you should go back and at least learn the basic technologies that relates to cyber security, and then at some point of time you have to decide whether you want to move into blockchain or what exactly is it. Blockchain use कर रहे हैं, then see, whatever the environment that you are trying to use, you have to be very much into the fact that it has to be secure. Okay, आप blockchain use करें या machine learning की security सोची है कभी आपने? ML algorithms that you are using, are they safe? No, they are not. Because suppose अगर आप कोई algorithm which has already been developed by somebody else, if you start using it without properly checking it, obviously at some point of time वो भी आपके लिए एक security का concern बन सकता है. People can manipulate even the data sets. they can manipulate the machine learning models. आप पढ़िए, अभी से नहीं, हम खुद करते हैं उनको, हमारे पास भी specific people हैं जो ये काम कर रहे हैं. You should understand that machine learning is itself a kind of security pool that you have to make it out. So with this, what I think, so I should close off because obviously people have to leave. In case if you have any specific questions, you can ask, and I hope. Thank you for patience listening. Thanks a lot. So, any specific concern? Yeah, please. Sit. Yeah. See, cyber security deals with multiple facets. Okay, you have like vulnerability assessment, you have penetration testing, you have malware analysis, memory forensics. See, blockchain is such mechanism where you can actually use it to have a safe environment, to have a trust kind of a thing. Okay, because earlier what happens, there are trust issues. So related to that, at least we can use blockchain for that application, like for health record systems. So I don't know whether that can be manipulated or not. So if I want that it should not be manipulated, if there is any sort of manipulation that is done, people should know it and it is based on consensus. So that is why blockchain has become an application. But अगर आप बोलो कि इसको कहीं पे भी apply कर दें, that is not the correct thing. So cyber security is the entire umbrella and blockchain is trying to assist you to create a secure application. That is what we are trying to do. See, Bitcoin is altogether a different facet that we have. See, in India, as of now, after 2018, we do not have any such regulatory to actually use the Bitcoin and specific other details of that. But Ethereum being obviously the highly capabilities and the use that we have, so that is why everybody shifted to Ethereum. So Bitcoin has an altogether different mindset that for doing the transaction, to doing the other things, we were using this. But there was no record. So it may be an illegitimate transaction, it may be a legitimate transaction. So that is why people have refrained from using that part of this. But still, in other countries, obviously people are not only using Ethereum, they are using that part of Bitcoin, and as well as there are other blockchain mechanisms that are available. So it depends upon the regulatory and kind of mechanisms that you have. See, in digital forensics, only that you can use, because we have also started something into the implementation of chain of custody form. See, chain of custody is a form that we go and basically we collect. So we are actually bothered about कि कहीं कोई आपने manipulation तो नहीं किया. So we can actually create a block where you can actually write the information that this was an incident, and then it passes from the Caesar processor to the person who actually do the entire imaging, the artifact collection and analysis, and then they have to report. So all that can be on a blockchain. But see, as of now, the cost of implementing a blockchain into that dimension is so huge. So अभी थोड़ा सा refrained है. Ethereum ही use करेंगे. People are trying to use Hyperledger Fabric also, but that depends upon the use case. So वो ही करें. Anything else? Okay, I think so. We are good to go. Thank you.
A thoughtful and insightful session. It was indeed a privilege to learn from your rich academic and research experience, and I am glad sure everyone here gained a valuable takeaway to reflect upon and explore further. As a token of gratitude, may I now request Chief Proctor PSIT, Mr. Astos Pandey sir, to kindly present a memento to Dr. Anand Handa sir. Thank you once again, sir, for gracing us with your presence. Thank you so much, sir.